Hi, I'm Megan Gamendon, and today we're going to be talking about integer partitive division. So let's go. We'll start with the definition of partitive division, and this is having some amount of stuff shared equally between some number of groups and determining how much ends up in one or each group. So to make sense of this, we'll use cookies. And the problem that we're working with today is 2,890 divided by 34. And this 2,890 represents our cookies, and the 34 represents our groups. So we want to know how many cookies does each group get. So we'll set up the algorithm, 2,890 on the inside, 34 groups on the outside. And we'll begin by stating that the biggest place value that we can work with is the thousands place, right here, or cubes. So we want to try to fit into 2,000. So we'll start by saying 1,000, 1,000's place, cookies into 34 groups. Does that work? Well, we'll try it. 34 times 1,000, 34,000. No, that's way too big because we only have 2,890 cookies. So we'll put a dotted 0 above to mark that no cookies fit into the thousands place. Now we'll try again with the hundreds place here, the 800 in 2,890. So 100 cookies into 34 groups. Well, 34 times 100 equals 3,400. And this still doesn't fit into 2,890, so no sets, 0 goes above the 100's place. So now we'll move over into the tens place, the 90 value. So we'll ask, can we split up our cookies into 10 cookies into 34 groups? Yes, we can, because 34 times 10 equals 340. And we want to know how many times 340 can fit into 2,890, and it fits in 8 times just through guess and check, because 340 times 8 equals 2,720. So over on the side, if we say 2,890, our beginning number of cookies, and we subtract 2,720, we end up getting 170 cookies left over, which is why when you look up here, we're ignoring the 0 because we're not working with our singles place right now. As I stated before, we're working with our tens digit. And so we only write 272 out of the 2,720 because these are the digits that we're working with right now. And so we subtract 272, and then 9 minus 2 is 7. And then we subtract 7 from 8, so we get 17 here. And 34 does not fit into 17 within the algorithm, so we'll drop our 0 because now we're working with the singles unit, finally. So 17 becomes 170 because we added on the singles digit. And we'll find out if one cookie can fit into the 34 groups, and yes it can, because 34 times 1 equals 34. And 34 times 5 sets equals 170 exactly, which is how many cookies that we had left over from before. So we'll subtract 170, which is what we found, and we'll find that there are 0 remaining cookies. Oh, and as a side note, we placed the 8 above to represent the 10 cookies in each group, going into 8 times 8 sets into the 34 groups, and then again the 5 goes above to represent the singles digit, the 1 cookie going in 5 times or 5 sets into the 34 groups. And so our answer is actually 85 cookies to each of the 34 groups.